11. Using several methods of factoring, we are going to put everything together. And here you're going to start to see all different kinds of problems, and you have to figure out how to factor them. There are some steps listed in your book. I'm going to try to abbreviate as much as I can so that we don't spend too much time writing. The first thing, I'm adding a step though. If you are looking in the book, it's a good place to reference, but I'm going to add a step first before theirs. First, write in order, highest exponent first. So that's if you get one that's out of order, where let's say it starts with x and then later there's an x squared, something like that. The first thing you want to do is try to put it in order with the highest exponent first. That's called the highest degree. The exponent is the degree. So that's step one. You may not have to do that on very many problems. Step two. Factor out the greatest monomial factor possible. After I give you these steps and we do sample problems, I will go back and refer to these steps so that you can get a better understanding of what each of these means. For those of you just coming in, for lesson 511, we're putting together everything we've done this chapter for factoring and combining it. Step 3, now I'm combining again a little bit from our book. They have this as, what I'm going to say here, they have this as step 2 and 3. I'm combining it as 1. And I'm going to say, look for a pattern. We had 2 special patterns in this chapter. We had the difference of squares, the difference of 2 squares, or 2 perfect squares, was one pattern. And what I'm going to do here is try to write down the lesson number next to it. This was lesson 5.5. We also had the pattern square of a binomial, and this was that one with a squared plus 2ab plus b squared. So again, that comes from lesson 5.6. So just if you forget those special patterns, okay, that's another step that we're going to do is to look to see, does it match one of those patterns? Because if so, that will help us factor it. Can you do reverse FOIL? So if it's not one of the special patterns, the square of a binomial or the difference of 2 perfect squares, if it's a trinomial, right, can you do reverse FOIL? Remember that means it has to be a trinomial. So like yesterday's stuff factoring by grouping, you couldn't do this. You can't do reverse FOIL. So again, I'm kind of changing a little bit of the wording. This is in your book as a list of steps. Some of mine are slightly different, but you should get to the same point. Okay? If it has 4 or more, I'm putting 4 plus, 4 or more terms, factor by grouping. Now, if you're doing step 5, because it has 4 or more terms, then you probably skipped 3 and 4. These are all about trinomials, right? These 2 patterns and reverse FOIL, that's for a trinomial. So if you want to put a little note off to the side that this is for trinomials. If you don't have a trinomial, you have 4 or more, then you'd skip those steps because these are only 4 trinomials and you'd come down to factoring by grouping. So again, we've done all of this stuff. Oh, in fact, step 2, factoring out the greatest monomial possible. Let me go back and say this is from 5.2 and 5.3. Okay, so that again, as you're going through these steps, if you forget what it means, hopefully that will help. Step 6, make sure each factor is prime. Now in the past, prime has meant it can't be factored at all. This means it can't be factored any further. It can't be factored any further. And again, I'll show you examples for all of these. Step 7, check your work. And again, we can check it by multiplying everything we get. If it's two binomials, you can FOIL it. If it's a monomial times a trinomial, you can do the distributive property. Okay, so let's start with some examples. As we do the couple examples I'm going to do with you today, I will refer to the steps. My steps may not show anymore on the screen as I talk about them, so just look at your notes if you can't see it here. First one we're going to start with, negative 4n to the fourth plus 40n cubed minus 100n squared. Now, step one, in order, highest exponent first. Okay, it's not just the highest exponent first, but then they go down in order. 4, 3, 2, we're good. We don't need to move anything. Step one, we don't need to do. Step two, factor out the greatest monomial factor possible. This means, is there something I can divide out of all three of these? Before you answer, let me just say that when we have a negative in the front, we might want to factor out a negative as part of our monomial. So let's take a look at the numbers first. 4, 40, and 100. What's the biggest number that we can factor out of all of those, Nana?
4.
Good, a 4. And because this first one is a negative, I'm going to factor out a negative 4. That will help us later on. If that's only for the first term being a negative. It doesn't matter what this last one is. What about my variables? What's the most amount of n's I can divide out? Diego? N squared. Again, this goes back to lessons 5.2 and 5.3. In 5.2, you were given this and you just had to divide it. So now, the next step is I've factored out, I know my first factor is this, and I need to see what's left. I see what's left by dividing each of these three by that term. Negative 4 divided by negative 4 is 1. N to the fourth divided by n squared. If I get rid of 2 from the bottom, I get rid of 2 from the top. That leaves n squared. And again, negative divided by negative makes this a positive. It's a 1. So that invisible 1, you can write it if you want to. Next piece, positive divided by negative makes a negative. 40 divided by 4 makes 10. N cubed divided by n squared. Again, I'm getting rid of 2 from the bottom, 2 from the top. Since there were 3, I have 1 left. Last piece, negative divided by negative makes a positive. 100 divided by 4 makes 25. N squared, I get rid of 2 and 2. They're both gone. That was just step 2. We don't need all of these steps on every problem. Step 3. Now, you could do reverse FOIL on this. First of all, let me say step 6. Make sure each factor is prime. It can't be factored any further. I can't do anything to this first one, negative 4n squared. It's just a monomial. But I can factor this. So this is what step 6 means. I can keep going with this trinomial. For trinomials, remember, I look at step 3 and 4. You can always try reverse FOIL on any trinomial. I'm going to, on this one, check the pattern to remind you how this works. Square of a binomial. Underneath here, I'm going to write the pattern for what this would be. If this is a square of a binomial, I'm actually going to write it above, I changed mine. A squared minus 2ab plus b squared. If that's the pattern, if this matches, then that means it comes from a minus b times itself to the power of 2. So I'm going to check and see if this piece matches that. Now again, you can do reverse FOIL, but you do need to be able to use this pattern, so I'm going to review it since this one might fit the pattern. If this is my a squared, what's plane A? If n squared is in the a squared position, what's plane A? Daniel?
N.
N. If 25 is in the b squared position, what's plane B? Jim? 5. Now I have to double check. This in the middle is 2 times my A times my B. That would be 10n. That is 10n. That means that this works. Now, I had my first factor, the negative 4n squared that we pulled out, and I've got my n minus 5 squared. If you were to just do reverse FOIL on the trinomial, you should get n minus 5 and n minus 5. The same thing twice. you can write it with the exponent of 2 like I did, or you can write it the same thing twice side by side, but make sure you have it as the exact same, both with a minus. Questions on that example? Now, it doesn't have 4 terms, so we're not doing that. We already checked to make sure, could I do anything to either one of these? There's nothing else I can do. To check your work, you could write this out, you could FOIL it, and then multiply it by that. We're going to skip the checking for now to save a little time in the podcast. Next example. I need to show you a couple just to show you all the different possibilities. 5a cubed b squared plus 3a to the 4th b minus 2a squared b cubed. Here we need to stop and take a look at step 1. First of all, in terms of the exponents, we're looking at the first letter. If it has more than one variable, we can't look at both, right? Here, the b's have different levels, so we look at the first alphabetical letter. Which of these terms should go first according to the a exponent? Again, just looking at the a. CJ?
3a but 4b.
Yes, the one with the highest exponent needs to go first, keeping its positive sign. Which one would come next? Again, looking at the A, just the first letter, right? So we've already done that one. Which one comes next between these two? Daniel?
5a.
Yep, the one with a cubed, right? So a to the 4th, then a cubed. That one is positive because it doesn't have a negative in front. Finally, last is this negative or minus 2a squared b cubed. So there's an example of using step 1. Okay, so just look carefully. Check before you start. Step 2, the highest monomial factor that I can factor out of all 3. 3, 5, and 2. Is there any number I can factor out? No, right, other than 1, which doesn't help. What about the variables? Let's start with A. What's the most amount of A's I can factor out? Diego?
A squared.
Good. B's. What's the most amount of B's I can factor out of all 3 pieces? Luke? Just 1 B. Good. So a squared b is my first factor. My next factor, what's left over after I divide it out of all 3? 3 divided by the invisible 1 stays 3. A to the 4th divided by a squared. I get rid of 2 and 2. That leaves a squared in my numerator. B and B will cancel out. Next, the 5 stays. A cubed divided by a squared. I get rid of 2 from the denominator. That leaves 1 in my numerator. B squared divided by b, I get rid of 1b and 1b. I still have 1b left. My minus 2 is still there. A squared over a squared. The a squareds are gone. B cubed divided by b, I get rid of 1 and 1. That leaves b squared. Now, I'm going to tell you this one is not a pattern. It's not the difference of 2 squares. It's not the square of a binomial. So we're going to try step 4. I think I had it as step 4. Yes, reverse FOIL. I keep this factor here, that just stays, and I check to see, can I do reverse FOIL on this? The only way to get 3a squared is going to be 3a times a. The only way to get 2b squared is going to be 2b times 1b. Remember that you have to, I'm doing it in pen because I know what the answer is going to be. This is where you have to try different combinations. Okay, this was from lesson 5.9, where if you did 2b times 1b, it wouldn't work. But if I do it this way, and I check my outer, 3 times 2 is 6, a times b, ab, inner, 1ab. If I want it to be positive 5, I'd put a positive here and a minus here. My positive from my outer, my minus from my inner. I check, negative times positive makes a negative. So this one, in fact, did work. If it doesn't, you would just leave it as a trinomial if that didn't factor. But since it does, there's our final answer. I look at each piece. There's nothing more I can do to any one of those pieces. Again, you could check your work at the end by multiplying it all together. One more. I know. One more. Because I just want to show you different possibilities that will crop up. I know this is a lot. That means you don't have as many problems. Okay. Last one. A squared BC minus 4BC plus A squared B minus 4B. A squared BC minus 4BC plus A squared B minus 4B. First thing I want to say is, if you have 4 terms like this, we're actually going to skip step 1 also. We're not going to reorder it. 4 terms, we skip all the way down to step 5. If it has 4 terms, factor by grouping. We're not doing anything else. We can't have factor anything out. There's nothing they all have in common. That's why we factor by grouping. So I'm going to make my 2 groups. So this is a review of yesterday's lesson. From each one, I will factor out the most that I can. The first term, I can factor out a B and a C. And in the second term, I can only factor out a B. If I do this one, I've got the BC. Let's see what's left. The B and the C would cancel out first, and I get A squared. Oh, the B and the C cancel out of the second piece, and I get minus 4. So B and B, C and C both cancel out as I go. In the next one, I've got my B, and I factored out. Let's see what's left. B divided by B, oh, those cancel out, leaving A squared. Okay, this looks good. These are going to match up. B divided by B, those cancel out, leaving minus 4. Okay, so far so good. This is a review of yesterday, and then we're just going to add one extra step. Don't worry, it's something you already know. BC plus B, okay, BC plus B reunited, A squared minus 4. Here's the trick on this one. Here is step, what did I say? Step 6. Making sure each factor can't be factored any further. This one can. Now again, this has been a little while. This is the difference of squares less than 5, 5. Let me remind you what that looks like. I'm going to write this off to the side. If you have 2 perfect squares, binomial 2, with it's always minus difference of 2 perfect squares, the pattern for this was that it's the exact same thing in the parentheses, but one is a plus and one is a minus. We haven't used this pattern since we did that lesson. So you got to remember it because it is showing up here again. I look at this and I know A squared is the perfect square of A times A. 4 is the perfect square of 2 times 2. If this is my A squared and this is my B squared, then plane A and B, if we were to FOIL this, the outer and the inner would be exact opposites and would cancel each other out. So here's that step 6. Can it be factored any further? Watch out for that difference of 2 perfect squares. Often we see a binomial and we think we can't do anything. But if it is that pattern, we can factor it down. Whew, that's it. That's all.
Yes. I don't